All right. So, should we continue with the papers that we were going through last time?
Um, wait, actually, so I think so. I went through them because on during the class, the teacher went through it with us.
Okay.
But I think for yeah, I don't think I have problems with any of them.
Okay, good. All right. So, what are we doing today?
I think we continue with biology.
Okay. Let me bring up the book. Man, it's supposed to get even colder now. I heard that it's gonna get like 7 or 6 degrees in some places. It's like playing havoc on my asthma. I've had like asthma for like the last week.
Oh,
It's been really bad. I don't think I've had a good night's sleep for a week now. I've always been just waking up wheezing.
oh.
How are things with you?
Um. Well, because I guess I sneeze and cough a bit more,
Yeah.
and I usually like go out for running, and
Okay.
when I tried it last week, it left a like a mint feeling in my throat, and it
Right.
still has. I think it got better, but it's really weird because it felt like even when I was breathing in like warm air, it felt like uh cold air.
Yeah. Yeah. Oh man. Oh, it's just like usually when it's gradual, your body can acclimate to it over time,
Yeah.
but it's so sudden. Like from being like 20 degrees plus to like 10 and that's crazy. Hopefully I mean, it's supposed to get worse, but hopefully January will start to, even though it's cold, our bodies will get used to it.
Yeah.
What page were we on?
Um, I think we're on uh, so
Did we
we did
finish nerves?
we finished kidneys.
Oh, yeah, yeah, we on kidneys. Right, right, right. Uh, okay. Do we also do page 121 of the PDF?
120. Uh, no.
No, right? Yeah, because I feel like we just stopped right before that. Okay. Okay. So when we look at different and diverse animals, uh, birds are similar to us. They're warm-blooded like us, even though they're in a different category. Um, reptiles are cold-blooded, right? So that means the environment dictates their body temperature. That's why they have to keep moving from land to water, vice versa, or like snakes have to go. They have to hide in the shade because they don't want to overheat, things like that. Insects are the same. So if they get too hot, then they just start to die. So they have to find shade. With mammals, same thing, right? We have a constant body temperature. So if you have a constant body temperature, we call them homeothermic. Okay?
Okay.
Another word for them. So homeothermic is the process. Homeotherms are the animals.
Okay.
Okay, good. And this is really interesting. So if you go bottom of that page, you should see the body temperatures of a few animals.
Oh.
Which animal has the highest body temperature?
Um, a mouse? Wait, no, a wren? Wait, oh, a duck.
A duck, yeah. And can you guess why?
Huh. Uh, I don't know.
Oh, okay. So what's a big difference between a duck and us?
They they're usually on water.
Right. But what else can they do? They have another ability that we don't have.
Oh, feathers?
No, no, ability. Something they can do, not something that they have. What can ducks do that we can't do? They
Hmm.
can fly.
Wait, wait, really?
Yeah, ducks can fly. Yeah.
Oh,
So when you okay, so like right now when you're sitting and we're just talking, even when you're not doing much physical activity, you're still releasing heat because when you do respiration, because respiration is not a very efficient process, you lose some of that energy as heat, right? So when you feel cold, the reason why you shiver is because your muscles then do more respiration. Because when you shiver, your muscles are moving, therefore you do more respiration, therefore you release more heat. That's why
Mhm.
when you're running, you sweat because again you do more respiration, you release more heat. So when you fly, flying is such an energy intensive process, right?
Oh,
So you're going to release more heat inevitably. But like you said, ducks are also in water. And you know that water has a high specific heat capacity, right?
uh, yeah.
And because it has a high specific heat capacity, when they land on water, water wants to absorb all of that heat. And that's not good for the duck because it's losing all this heat. So how does it then balance that out? By having high body temperature.
Then when they have to like uh eat a lot of food.
Yeah, yeah, yeah. They're constantly hungry. But luckily for them, they're sitting on their food source.
Oh,
Well, that's why, like, when you when you go to like feed the ducks in a lake, they're constantly hungry.
oh.
No matter how many breadcrumbs you give them, there are always some ducks that want them. So, yeah.
Wait, then what about like I remember there were like a species of birds that have to, I don't know the English name for them, but they have to like fly very long distances like through the season changes.
Oh, are you talking about albatross?
I don't know. Um,
They're one of the largest birds in the world, albatross. And they fly like huge distances because they're migrating.
oh,
Yeah.
so do they have like a higher average body temperature?
Ah, good question. Okay, so this relates to surface area. Okay, when you are larger, what happens to your surface area to volume ratio?
Um, your volume increases faster.
Exactly. So if you are a large bird, then your body temperature doesn't need to be so high because you have a larger volume to keep that heat in and to generate that heat. When you're a small one, a small bird like a duck, because an albatross is like 6 or 7 times bigger than a duck. When you're so small, your surface area is larger than your volume. That means you lose heat quicker. So your body temperature must be higher.
Oh,
Because like think about this. If your theory is the bigger you are, the higher your body temperature, then shouldn't that apply to mammals too? Shouldn't like polar bear, but if you look at polar bear, their temperature is just like it's similar to ours. But a polar bear is bigger than us.
oh, okay, yeah.
So if you look at all the birds, you'll see birds are 40 and above, right? Wren, thrush, penguins are probably the exception, but like ostrich is close, right? And then if you look at all the mammals, they're closer to body temperature to us.
Yeah.
Excellent. Now, curiously, why do you think a mouse's body temperature is almost 40? Any
Uh,
theories?
uh, maybe like the volume to surface area ratio.
Right, right, exactly. And also where they live, right? They live underground.
Oh,
So it's often cold underground, right? Because ground heats up quickly, but it also cools down quickly. That's why the South Pole is colder than the North Pole. North Pole has a lot of ice, not a lot of land. South Pole is all land. So the ground gets colder. That's why South Pole is colder than North.
wait. No, I didn't get it.
So whenever you have land, land can heat up quickly or it can cool down quickly.
Oh,
Because water has a high specific heat capacity compared to land, right? So in the north, where you have a lot of ice, so when polar bears like when they hunt, They hunt on ice. They don't hunt on land because when the ice freezes, when the water freezes, right? They go on that ice, that freshly frozen ice. They make a hole in that ice. They wait for sea lions to come up to take a breath, and then they catch them.
Oh,
So they need ice. They don't need land. And that's why they can live there. But if they go to the South Pole, the reason why there's no polar bears in the South Pole is because South Pole is mostly land. The ice is on top of the land, not frozen. I mean, there is some frozen ice, but the reason why it's colder in the South Pole is because of the land. Because the land absorbs all this cold and it keeps this coldness.
right. So, wait, then if the water has a higher specific heat capacity, does that mean it takes longer? Oh yeah, it takes longer to heat it up. And
Right, right.
okay, yeah.
Yeah, excellent. Good. Okay, so the only thing I want to mention on that page is that they highlighted the word denaturing, right? So the reason why high body temperature is not good for you and me is because it would denature some of our enzymes, which would then uh, work against us when we have an infection, right? Because remember, white blood cells release, like phagocytes release lysosomes, which are enzymes, right? So if you are going outside that 37-degree boundary too much, then it could interfere um, with our metabolic processes. That's why having like uh, 38.5, 39 degrees fever is very dangerous because then it actually starts affecting respiration, which means you getting less energy when you need more energy to fight off whatever you're fighting.
Wait, how does it affect your respiration?
Because and you learn this in A levels, but the process of respiration, so far from what you know, is just that chemical equation. But when you do A levels, you'll learn all the minute steps in it. All these steps require multiple enzymes.
Oh, okay.
So if one of the enzymes fails, then everything in front of it fails. Because when one enzyme breaks something down, the product of that is used in another process of respiration. And then the product of that is used in another process of respiration. So it's like a domino, right? You need all the dominoes to fall in order for something to happen. But if one domino doesn't fall, then anything else in front of it doesn't fall.
So the respiration, just this one equation takes multiple processes?
Right, it's multiple steps. You learn this in A levels, but there's three main steps. So one is called glycolysis. Then it's actually four steps: glycolysis, pyruvate oxidation, Krebs cycle, and electron transport chain. You'll learn that these four processes are the main processes that do respiration, and the product, like the sequence I mentioned them in, they go according to that sequence. So the product of glycolysis goes into pyruvate oxidation. Product of pyruvate oxidation goes into the Krebs cycle. The product of Krebs cycle goes into electron transport chain, and then respiration is completed. And each of these uses multiple enzymes to accomplish what they need to do to create products. So, for example, right, just the first one, glycolysis, is responsible to take the 6 carbon sugar, because C6H12O6, and to break it down into 3 carbon sugars. So instead of C6H12O6, you have C3O3 and H6, like that. So you're supposed to break it down.
Okay.
But if that is denatured, then you can't even start the first step, which means you can't do the others.
Oh, alright.
Okay, good. One of the animals they should have mentioned here is the bat, because the bat's body temperature is quite high.
Oh.
It's about like 40 to 43 degrees.
Oh, 40.
Yeah, I think future books will have it because of COVID. They'll probably put it in the virus chapter.
Oh,
Okay, next page. Thermoregulatory center. Right. So obviously, your brain controls everything. So why not, right? It has a a thermoregulatory center. It's responsible for making sure that your body temperature is within those bounds. But this is quite a complex process, right? Because let's think about this. When you do respiration, you keep building heat in your body, right? When you keep breaking down glucose. But then you need to slow that down because just too much heat. But then when you slow it down, your body temperature decreases, you got to increase it again. So your thermoregulatory center is the place where they constantly send signals to your cells to increase respiration, increase, decrease. Like it keeps it within a range.
Oh,
Because, like it's not like it can set a certain, like it can say, okay, 37 degrees, that's it. It needs to keep it within a range. So sometimes it'll be like 36.8, sometimes it'll be 37.2. This is what your air condition does, right? So
oh,
let's say you set your AC to like, I don't know, like 24 degrees, and it'll start to turn on. And as soon as it hits 24 degrees, it will turn off. It will wait until the room temperature starts to increase again, and again it'll turn on.
yeah, yeah.
Yeah, just like that.
I have a question. So, like, when you're like in a colder environment, you have like vasoconstriction.
Right?
Wait, what is it called? Vaso.
Vasoconstriction.
Yeah, and then that would decrease blood flow. Then
Right.
so wait, I heard that. So when you have a higher blood flow, you have a higher body temperature.
Right.
Then if you try to like if you constrict your uh blood flow, then wouldn't that mean you're getting like you're not producing as much heat?
So okay, let's think about this. Okay, when you say constrict, what we mean by that is that we are increasing pressure, right? Because the blood has fewer places to flow through, correct?
Yeah.
Increasing pressure does not necessarily mean decreasing heat, right? All it means is that blood is flowing faster. In fact, you're increasing heat because blood is flowing faster.
Oh, really?
Doesn't the okay? If let's say water can flow through 5 places, if I close off one of those places, now the same volume of water is flowing through 4 of those places.
Yeah.
Wouldn't the pressure increase?
Yeah.
Right? So because blood is flowing around your body faster, you're getting oxygen faster. Therefore, you can do respiration faster.
Hmm. I don't know, but I got like I'm a bit confused because I thought that like if your veins and arteries were more loose, then more blood can flow and then more heat can be. I don't know.
So, okay, maybe let's think about this conversely. Maybe that will help. If your blood flows closer to the skin, you release more heat, right?
Yeah.
So obviously, blood flowing farther away from the skin would decrease the release of heat, right?
Yeah.
So for vasoconstriction, vasodilation, that is it. Now, whether your body chooses to do something else to increase the amount of heat is separate from vasodilation, vasoconstriction. Because, okay, let's say, for example, you're in your classroom, right? And you forgot your jacket one day, so you're feeling cold. But you're not really feeling so cold. You're feeling cold. So your body does vasoconstriction, you get goosebumps, right?
Yeah.
But you're not shivering, are you? It's not so cold that you start shivering, right?
Yeah.
So your body chooses what to do based on the situation. If you were shivering, then your rate of respiration would go up.
Oh.
Because all these actions take energy. So your body won't needlessly increase your body temperature if vasoconstriction can help. Because remember, your skin is your largest organ, right, in your body. So
Yeah.
if you do vasoconstriction all over your skin, that should reduce heat loss substantially.
Yeah. Yeah.
Right? Good.
Um.
Excellent.
Yeah. One more. So.
Mhm.
Uh. Like senior people burn more energy, right? Then.
Right.
Then wouldn't that mean they would have higher body temperatures?
Correct.
So. If like a chubbier person and a skinnier person, if they have like the same environment, and then
Hmm.
you measure uh their body temperature, then should the skinny person have a higher body temperature?
Okay. Before I answer that question, we're ignoring a really big aspect of what you're saying, which is metabolism. We have our own metabolism. So just because a person is skinny or a person's overweight, it's not so easy to predict what, like, you know what I mean? It's not so easy to predict, like, what rate of respiration they're at. Because if a person who's overweight has a slower metabolism, then they're releasing less heat. Person who's skinny has higher metabolism, releasing more heat. But it could be opposite. The person who's overweight can still have a higher metabolism than the person who is underweight.
Wait, then how does that work?
It's just what they're born with. It's
But
genetic.
like the energy, like chemical energy inputted cannot like it can be either stored or released. Then how would
Your
that work?
body always chooses to store it over releasing it. That's why people gain weight.
Wait, then why isn't everyone the same?
Because of different rates of metabolism, right?
So that determines that determines your rate of uh
Exactly.
okay.
Your rate of respiration.
Oh yeah, rate of respiration.
Yeah. This is why some people are well, I guess maybe in today's environment we might say they're lucky because no matter how much they eat, they're skinny. But one day we'll have food shortage right in the world. And then those people who can store, I guess, glycogen and fat more efficient will be the lucky ones.
Uh-huh. Yeah.
Survival of the fittest. Okay, let's go through the skin. Seems like you already know some stuff on the skin, so let's go through the rest. Okay, skin has quite a few functions. So on page 122 on the bottom, you'll see that there's 5 things they highlighted, right? So the first thing is tough outer layer and resists mechanical damage. Okay, this is just your epidermis, that part that you see in the diagram. That's the thing they're referring to. The second part is a little bit different. They didn't explain it, so I want to explain the second one a little bit. Acting as a barrier to the entry of pathogens. Now, this can seem quite intuitive, right? Smooth skin, bacteria can't get in. That's what they mean. But that's not all what they mean. So, our surface of our skin doesn't start with the epidermis, actually. It starts with a layer of dead skin. So, think about it this way. When you see trees, do you know what a tree ring is?
Uh like a year of growth?
Right, right, right. So it grows from the inside out, right?
Yeah.
Like that's how a tree grows wide, inside out. And think of our skin like that too. Our skin grows from the inside out. So if, let's say today, your epidermis is a certain, it's a certain level, tomorrow your skin will grow from underneath that level and will push the previous level up. And so yesterday's skin becomes today's dead layer on the top of today's skin.
Hmm.
That's why you shed skin cells, because your skin cells are growing at a prodigious rate, right? So they're one of the cells that constantly do mitosis. right? They
Oh
keep
yeah.
replacing and that's one of the reasons why skin cancer is one of the most prevalent cancers in the world, because if you're continuously doing mitosis and you continuously spend time in the sun, then there's a high chance that one of those UV rays can hit some cell that's undergoing mitosis and can cause something to go wrong, and then that cell that's still dividing can turn cancerous,
Oh yeah.
right? So if you put sunscreen, then that sunscreen acts like a layer on top of your skin, which absorbs most UV light. So it decreases your chance of getting cancer dramatically, depending on how light your skin is. If your skin's already dark, then of course more protection. But if it's lighter, then it can dramatically decrease the rate of skin cancer.
Does
Okay. Mhm.
does darker skin prevent more UV rays?
Oh yeah, for sure. This is why people who live in the equator or just under the equator, like parts of Southeast Asia, parts of Egypt, that parts of Africa, their skin is darker than people who live in the northern latitudes, for example, because just from the amount of solar radiation they just receive much higher of it. Of course, because the equator, like the Earth bulges at the equator, right? So we're technically closer to the sun than people who are at the northern latitudes, right?
Yeah.
So just per year, the amount of radiation we're exposed to is much higher than people in the northern latitudes. So over time, over like maybe five, 600,000 years, people who live within these latitudes have evolved, and they like evolution has chosen darker skin over in favor of lighter skin in these latitudes.
I want to ask, like if you're under the sun, like usually a person out in the sun more often than another person, then they get a darker skin tone. Then is that related to like people living at the equator? So,
Okay, let me clarify. Are you talking about getting tan?
yeah, that.
Okay, okay. Oh, good question. So, okay, here's what happens. Your body is like, man, this is like a lot of sun. Your skin is not used to this much sun. So we need to release some melanin. We need to release some of these dark pigments to temporarily make your skin darker. So becoming tan is in response to getting more sunlight, but it comes at a cost because it's temporary, right?
Yeah.
And you cannot become so dark. Like there's a maximum amount of tan you can be. So when you stress your body out so much that you're so tan, then that means that like if there's more radiation, then you can become tan. Then your chance of getting skin cancer becomes dramatically high because those skin cells, aside from constantly dividing, now they have to produce this pigment. So you're asking them to do multiple
Oh,
things at the same time, and when they do it for a prolonged rate, let's say you fell asleep in the sun or something, then you don't get protection. What you get is, the peeling of your skin. You get sunburn
oh.
because you've killed those cells, right? Those cells are you've overstressed them and they're dead. So your skin peels and peels and peels until we find a layer of cells that is alive.
Wait, does when your skin gets like uh oh it burns, is it because they're trying to produce like the tan thing?
Right, melanin.
Oh yeah. And or is it because they're actually being destroyed by the rays?
It's kind of a bit of both.
Oh, okay.
Yeah, I guess it depends like how strong the solar radiation is, right? If it's really really hot, then I would think that that the heat itself is what's killing them. But if it's like not so hot, but you fell asleep for a prolonged period of time, then I would think the stress is killing them.
Oh,
Yeah, it depends on the situation.
okay.
Okay? So going back to what I was saying, the dead skin cell layer is another layer that's your first line of defense against pathogens is your dead skin layer. So, interestingly enough, okay, people who shower and soap themselves every day seem to get sicker more often than people who use soap every other day. Why? Because soap removes your dead skin layer.
Oh.
So these pathogens have direct access to your epidermis.
Oh, yeah.
Now, if you don't live in an environment where you're surrounded by pathogens, because we're always surrounded by bacteria, but being surrounded by pathogens is different, right? So if you live in a country where cleanliness, hygiene, all that stuff is fine, then it's okay. Then but if you like, let's say if this is your habit to do this every day, and then you go visit a country where it's not as like the sanitation is not as good as in your country, then you most likely get sick in that country because you know you're losing one line of defense which you need in that country.
Yeah.
Okay, good.
Um, but I have a question
Hmm.
about like the tree, like the
Tree
tree,
ring.
yeah, rings.
Hmm.
Um, th- like how, because you can clearly see like each ring represents 1 year.
Yep.
Did they just like how does that happen? Did they just make a new layer every year, or
Oh, so the and you learn this in A levels too. So the way it happens is like the inside of the tree is like our skin. It continuously does mitosis. Okay, so it just because we have four seasons, right? And in every season the tree is going through something different, right? In winter the leaves fall, in spring the leaves come back, and then in summer they sort of like flower, and then you have this pollination, and then autumn the leaves fall again, and winter they hibernate, right? All that stuff. So they know that 1 year means four separate events for them, right? So in every separate event this tree ring growth responds in a different way. So it happens to be that after the fourth season is done in a year, then that's when they go back to doing what they were doing in the first season.
oh,
So that is what a tree ring means. It's less to do with 1 year. It just happens to be that four seasons equal to a year. It's more in response to the season. So when they go through season one to season four, that's one tree ring. Because then they go back to doing what in season one, what they were doing in season one.
yeah,
Right? So
okay.
good. Okay, the third point. Forming an impermeable surface, preventing loss of water. Okay, that's self-evident. Because we have pores, and pores release sweat, but we also have hair that's protruding through the epidermis, and the hair has something called an oil gland. Now, that oil gland can spread over your skin, and it can form that impermeable layer preventing water loss.
Does it also defend against pathogens?
I mean, it can, but most likely than not, it causes problems like acne and stuff like that.
Wait, what?
Like more likely than not, it causes acne.
So it's more likely to cause acne than to defend?
Right, because all these biological adaptations evolved when we were cavemen and women. Like when we were cavemen and women, my statement would be converse of what I just said,
Oh,
because you're constantly exposed to pathogens. You live in an environment, but because we live in such a sterile environment now, it's kind of more of a hindrance than an adaptation.
yeah.
Yeah? Good. Okay, fourth point, acting as a sense organ for touch temperature changes. So if you look at the diagram right under there, you'll see you have pain receptor, pressure receptors, temperature receptors, right? I want to talk about their positioning for a second. Okay. Now, if you look at pain receptor, it's closer to the surface, right? As
Yeah,
compared to the other
yeah.
receptors, I mean, which makes sense, right? You don't want to cut yourself so deep, and then you're like, ouch, right? You want it to be closer to the surface.
Yeah.
But now let's look at the pressure receptor. Now, pressure receptor I find the most interesting. Okay, when you get bit by a mosquito, most of the time you don't know the mosquito's there, right?
Yeah.
You only feel it once the mosquito leaves, correct? Because their saliva has some chemicals that then make you feel itchy. You have an itchy bump.
Yeah.
But by the time the mosquito's gone, the reason for that is that they're so tiny that your pressure receptor doesn't detect them.
But usually when you detect them, it's because they move the hair.
Not necessarily. They're still really small. Because look, even if they move your hair, you have to sense that, right? Because that vibration has to go through your skin into the pressure receptor. But because they're so small, you might just accidentally interpret that as wind,
Oh, yeah.
right? So, and this is one of the reasons why the pressure receptor is so deep. Imagine if you can feel constant wind.
Oh,
Like you usually feel wind when it's windy, but imagine just walking in the street when it's not windy and still feeling the wind,
yeah.
right? That would be really annoying. So that's why it's much deeper. Now, temperature receptor has to be deeper because if it's not deep, you're constantly sensing the outside environment, right? Like you don't want to constantly be exposed to that. You want the temperature to come to you deeper because when it's penetrating so deep, then you're like, okay, we need to sweat it out, or we need to shiver so we can like generate more heat.
Yeah.
Okay,
Um.
excellent.
Uh. Wait. Oh, yeah. Yeah. So, like for the, because when you move the, I feel like when you move the hair of the skin, you feel it more than when you feel the pressure on the skin.
Right, if you look at the hair, right? If you look at where it's situated, it's more closer, like the root of the hair is closer to the pressure receptor. But the stimulus has to be large enough to transfer to the root of the hair,
Oh, yeah. Right.
right? So,
And I remember one time when I was in physics class, they showed like electrostatic like force.
right,
So they had this. I think it was a ball that had static electricity on it, and I
right,
didn't have to touch it. I just moved close to it, and I felt like wind. It felt like wind blowing, but it was
right.
actually the hair being attracted or repelled.
Right, right.
Wait, wait, it's yeah. I think it's repelled.
Hmm.
No, it should be attracted first, right? Because
So if
well,
you use a ruler, it's the same concept. When you rub a ruler, you're rubbing off all the electrons. So the ruler's left with positive like protons, right? So when you're attracting it to your hair is more negative on the surface. So that's why your hair gets attracted to the ruler.
wait, so if the ruler is like positive, then would like negative electrons would move towards it while like the positive charge would be repelled
Right.
to the back, then the negative uh then the negative would be stronger because it's closer to the positive.
Right.
I wanna I'm wondering if a person didn't have hair, then would he be able to
Feel anything.
feel like wind?
Actually you would because okay, when you say no hair, you can't really guarantee that there's no hair, even if they're like shiny bald, because you still have your pores, right? And maybe tiny hairs growing and you just can't see it. So I would say more likely than not, they could still feel it. But if you're saying somehow you can guarantee that they have absolutely no hair at all, then they can't feel it.
Oh, wait. Then even when I feel like feel wind blowing by my ear, like I actually like stronger wind. Then what if it were stronger? Would you?
Wait. Now, when you say wind, now, do you actually mean wind, right? Not like particles, like electrons and protons.
Like actual wind?
Okay, yeah.
Yeah, so your skin would pick up like the pressure receptor would pick it up.
See, that's a bit different though, because your ear is an instrument for hearing, right?
Yeah.
So your ear itself, the the part of the outside part of your ear, the pinna, the part that like focuses the sound into your ear, it has more pressure receptors than, let's say, your arm or your leg. So wind near your ear would feel stronger than wind on your arm or your hand.
Okay.
Yeah, just because the fact that uh, it's designed for that, so it would have like different parts of your skin have different amounts of receptors. Like, that's why you're more sensitive on your hands in terms of pain. Like if you cut yourself like at the back, like on your shoulder, versus you cut yourself on your finger would hurt more,
Oh yeah.
right? Because the distribution of pain receptors is much higher with your finger because we explore with our hands. So it's more likely that we're going to get injured with our hands than compared to our shoulders.
So why is it that my elbow, like usually the elbow would have the least receptors, I think?
Right, right.
Is there like a an obvious reason?
Well, I mean, for one, the elbow is less likely to be the thing that would get injured because you're not exploring with your elbow, right? Um, the second reason is even if, like, let's say you're a soldier, and you know how soldiers do this crawl, right?
Oh,
And they're exposing their elbows all the time. And then what happens is because elbows are like quite tough compared to your hands, right? Like you can actually feel the bone through them, right?
yeah.
So because they're more tougher, they're less likely to be injured even if you get injured there. So it has more protection than your hand does. Your hand is so soft and squishy compared to your elbow,
Oh yeah, yeah,
right? So
yeah.
good. And the last one, controlling the loss of heat through body surface. Now we'll talk about this on the next page. Okay. So let's go to the next page, page 123 of the PDF. Okay. Uh, let's start with sweat glands. So when you are releasing a lot of heat during some physical exertion, your body's like, okay, we got to cool Chris down. Let's release all this sweat, and this sweat will then absorb the heat from the skin and then in turn evaporate in the air, cooling your skin down. So this sweat that you release has some water in it, but it has other components. Because think about this, if it was just water, you would actually feel hotter. Because when you go out and when it's very humid in summer, you feel hotter when it's humid than when it's not humid, right?
Oh yeah.
Because water is sticking to your skin. Water
Oh,
has high specific heat capacity.
oh yeah, right.
So it'll stick to your skin until it reaches a point where it's like, okay, I have enough energy to escape. So sweat has some water, but it's made out of many things because you need to lower that specific heat capacity.
But, when you feel hotter when it's humid, is it like that when you sweat, it doesn't evaporate and then your temperature receptors pick up like that heat covering your body?
Exactly, right, right. But the reason why you keep still overheating, even if it's humid, is because your body's trying to get rid of internal heat, even if it's having a hard time releasing that heat because it's humid outside. It doesn't change the fact that it needs to get rid of the heat on the inside. So it's not like your body says, okay, let's slow down respiration. You're feeling too hot. It needs to get rid of that heat on the inside because it will affect your rate of respiration, your enzymes. So that's why you keep feeling hot even though it's humid outside.
Yeah.
Okay, good. Okay, let's talk about the hair erector muscle. So if you go back to page 122 of the PDF, you'll see that the hair is attached to the hair erector muscle. This is why when you pull your hair from your arm, you feel hurt because you're actually ripping the hair erector muscle too.
Oh, really?
Yeah.
Wait, so you does that thing repair or regrow?
Yeah, it repairs itself. Unless you continuously, for some reason, do it at that exact spot,
Oh,
then the hair won't grow back anymore. It's
but
like a scar, right? If you have a scab and you keep picking at it, over time that skin will stop healing and become a scar.
oh yeah,
Yeah,
and
just like
and
that.
like when your hair just naturally, I mean like when your hair falls off on its own, then
Mhm.
how it yeah how does that work?
Oh, so just like your skin, right? Like how your skin has a certain amount of lifespan. So how does it know that, okay, now, we need to create a new dead skin layer. Let's start doing mitosis and then push the skin layer up. It's like that. The hair knows it has a lifespan, the hair root cell. And so when it deems necessary, be like, okay, we've had this hair for long enough. Let's create a new root hair. But before it can create a new root hair or a new hair, it needs to eject that hair, the one that it already has. Because the hair is not the part that's alive, it's just made of proteins. So when you eject it, then new hair will grow. Now, this is different to if you pull your hair. Because if you pull your hair, you're also pulling the root of the hair. So that's why if you pull your hair and you touch the end of the hair, it's sticky.
Oh,
Because that's the cell. You actually pull the root hair cell out, right?
oh you then can it somehow regrow at that spot?
Right. But if you keep pulling your hair for some reason, you will go bald.
uh then so when your hair falls off on its own, it keeps the root but ejects the rest? Or
Yes,
oh, and that root can grow again.
exactly.
Okay. Yeah.
Good. Okay, so back to hair erector muscle. When you are feeling cold, one of the things your body can do, now this depends on how much hair you have on your arms and the rest of your body, but providing you have sufficient hair, your hair erector muscle will contract and will pull the hair up so that it's standing vertically. Well, not completely vertically, but more vertical than it was before. And the reason why they want to do that is because they want to trap a layer of air between the hairs, because air is an insulator, so that when heat from your body tries to rise up and come out, it hits that layer of air and then it re-radiates back down to your skin.
Yeah. Okay.
Okay, good. Okay, so that's hair erector muscle. Okay, so last one we're going to talk about is vasoconstriction, vasodilation on page 123 on the bottom PDF. So, like we discussed before, right? Vasoconstriction causes the sphincter muscle. Those sphincter muscles are those two black dots that you see that are closed.
Oh.
It says blood vessel constricts. It constricts because those vessels, those muscles close and provides an alternative route. And if you notice something, right? So there's two things I want you to notice. One is that that new route is shorter, right?
Huh?
The new route, the new like vessel that the blood is going through is shorter. The route is shorter than
Oh.
if the blood flowed upward, right?
Yeah.
So it's spending less time near the surface of the skin. So that's the first adaptation. The second adaptation is because it's flowing through fewer blood vessels, pressure increases, so it flows faster.
Yeah.
Okay, good. And then, of course, during vasodilation, you flow closer to the skin, so you radiate more heat. And then the last thing on page 124 is shivering, right? Your muscles continuously move, you do more respiration, you increase body temperature.
Um, so when you're shivering, to me it feels like when your body tells you that you need to shiver, it's already
Hmm.
to a point where shivering doesn't help.
Okay, I see where you're coming from, but the thing is, even if you can give yourself like 5 more minutes, 10 more minutes, I mean, that could end up saving your life, right? Because imagine if you're like stuck somewhere and you're waiting to be rescued. Anything you can do to prolong, like, because the thing is, once your body temperature gets below a certain level, different parts of your body start shutting off because they're trying to move like all the rest of the energy towards body parts that are more relevant to your survival. So, like, obviously, the blood flow to your stomach stops pretty much because you're not going to eat something while you're shivering. So, heart, brain, lungs, those three are the main. Then the brain starts turning off stuff a little bit. Then the heart starts slowing down. Then the lungs stops slowing because the heart slows down. And eventually then you give out. But if you shiver, you can keep blood flowing to those three places for a longer time.
Yeah. I So when you're like in a colder environment, your rate of respiration actually decreases, right?
So at first it increases because like like it's like when you're wearing layers and layers of clothes and when you go out and it's really cold. And then when you come back home, you want to take off those layers of clothes because you're feeling hot, right?
Yeah.
So your body temperature increased because the outside is colder when you went out. But when you came home, the environment is warmer than the outside. So you want to take off your clothes because you're feeling hotter. So your body actually increases the rate of respiration in response to the cold. But there comes a point where that strategy doesn't work. And so what happens is that it reaches a point where you're losing heat faster than you can generate heat because
Yeah.
it's so cold outside. Maybe if you're hypothermic or something. And because of that, your body says, okay, we need to focus the rest of this energy into shivering because that will buy us a few more minutes. So only the parts around where you shiver, the body temperature increases, but it's decreasing everywhere else.
Oh. Okay. And
Right?
because
Hmm.
I see people wearing jackets and exercising, and they they say that they do it to like decrease weight, to
Right,
burn more energy. But then,
right.
so being in a colder environment actually uh increases your rate of uh like respiration. Then they say that they say that higher body temperature also does the also uh increases your rate of respiration. And it's
Right. This is the myth of the sauna, right? So people are like, oh, let's lose some weight. Let's sit in the sauna. Let's let our fat melt away. um, okay, not saying that it's not 100% like it's like 100% false, but I mean, let's just think about it like scientifically, biologically, right? If you have high body temperature, you're doing all these things like vasodilation, you're sweating. All these things need energy, right?
yeah, yeah.
So you're doing extra tasks that require your body to do extra things. Obviously, you're going to lose some energy doing those things. But does that make you lose more energy than exercising? Definitely not. So it would take you a long time to lose that same amount of weight if you're sitting in a sauna rather than just exercising. Like Maybe if I do a one-to-one comparison, 30 minutes of exercising would take you like months of sauna.
Oh,
Yeah.
because I don't want to lose. Uh, I'm afraid of losing weight. So
Right.
when I hear people wear more clothes to lose weight, I like naturally subconsciously try to get colder, but then the other way around, like a theory, the other way around is explained, and it's kind of
Right, right,
functional.
right. Nah, I mean the amount of gain or loss or whatever is so minimal. It's like one of my students asked me, "Oh, I love reading books, but does that mean that the more books I read, the more weight I lose?" I'm like, "Well, how does that work?" He's like, well, "I'm using my brain, right? I mean,
Uh,
the more I use it, the I should lose weight." I'm like, "Yeah, but the amount of energy you use for that task is so minimal. Like by that estimate, the skinniest person alive should be the smartest person, right?"
uh,
So yeah, all these tasks like lose such minimal amount of weight is like yeah, you're better off going for a walk.
okay. So these are like myths and just
Yeah, yeah, they don't really like you'll see people like wear garbage bags and stuff and just go for a run. Nah, it 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 does like it's more of a hassle than it does like help. You know?
yeah.
Excellent. So just read from page 121 of the PDF till the end. Let me know if you have any questions.
For cold-blooded animals, do
Mm-hmm.
they? So if the temperature determines their body temperature, like the environment, then would would that mean that their body processes would like change according to the environment?
Ooh, what do you mean?
Like wait, so does a higher wait does that mean their enzymes are more adaptive?
Yes.
So um so a higher body temperature that would make their like chemical processes a lot faster, right?
Not necessarily. If you have a molecule that because like different enzymes work at different body temperature, different pH, right? They have different optimum pH, and so like if you have let's say something at pH of 2 that works at 37 degrees, like our in our stomach, for example. If I take that enzyme and let's say if I increase the temperature by a little bit, obviously the reaction will be faster. But if I increase it by significant, it will denature. But what if some enzyme works best at 40 degrees? Then 37 degrees means it's too low for that enzyme to be at optimum temperature. So every enzyme is suited to different temperature, different pH. So if you go above the optimum, obviously then it will be faster. If you go below, it will be slower.
Okay. Then wait, then why are some animals warm blooded and why are some cold blooded?
Because they adapted, they have different adaptation strategies in that environment. So, the thing is, right? Evolution doesn't have a script. It will change a body plan depending on its environment. Now, sometimes just by coincidence, multiple animals will develop the same adaptation just by coincidence. Like for example, the eye, right? You can see that almost every animal on Earth has an eye, right?
Yeah.
But it's impossible that the eye developed once and spread to all the other animals. Because some of these animals have been living apart for millions of years. It's impossible that one ancestor went to like Australia when it was, you know, Gondwana, when it was like one piece, and then it broke off, and then it's now Australia is a separate continent. That one ancestor survived all the way till now, right? So multiple adaptations can happen to same or different animals at the same time, or it can happen, or you can have the same adaptation over many, you know, many millions of years. So just the fact that the eye has developed so many times should tell you that like that you could have a cold-blooded creature in one environment, and then on the other side of the world, because the same like the same type of stressors, the environmental stressors are present just by coincidence, evolution came up with the same answer,
Oh.
right?
Um.
So,
Wait. I'm I'm curious. Like, how does an organ like an eye develop? Because how do you like just through uh evolution you just develop an organ that can sense like this uh specific part of like the electromagnetic spectrum?
oh, so okay, yes, so you went a little bit ahead, but you're very close to the beginning. So in the beginning, the theory is that you have these animals that cannot see, whatever these animals are, in the water, because that's where life began in the ocean. So they can't see, but just by chance, one of them had a mutation where they then created these balls of cells that can detect light, but not in the light that you and I think of it. Think of like, okay, if you, okay, just close your eyes for a second now. Take your hand and just wave in front of your eyes. Can you feel that as you wave in front of your eye, the light gets blocked, right?
Yeah.
And as you move away from your eye, you can sense some light even though your eyes are closed, right?
Oh.
So this is what was the first adaptation. They could sense the presence or absence of light.
Oh.
And that gave them an advantage because if your prey is above you, that means it's blocking light, then you know that's something there's blocking light.
Oh.
So so you become a more like you have an advantage where you can then pass on these genes and survive.
So it didn't start off like you could like actually see things. It's like you're just sensitive to light.
Exactly.
Okay. Yeah.
Yep. And then from there, like, over many millions of years, you collect several mutations where this ability becomes more refined. And to be honest, our eyes are not the pinnacle of eyesight. Do you know what do you call the shrimp? I I think they're called boxing shrimp. Basically, like they have these like boxing gloves and they punch their prey to break their shell because they eat snails. They're a
Wait,
type of shrimp.
is it the mantis shrimp?
Yeah. Mantis shrimp, yeah. And the mantis shrimp can see so many more colors than we can.
Oh, really?
Yeah. They can see body heat. They can even see a type of electromagnetic radiation like that are invisible to us. So and actually they use it as signals because the mantis shrimps are very aggressive. So if two mantis shrimps come together, they'll often fight to the death, and that's not good for either of them, right?
Yeah.
So when they're looking for a home, they'll like they'll look into that whatever that is, the coral, and this other mantis shrimp, if there's a mantis shrimp in that coral already, he'll have these like fins on the side, and they'll start moving, and they'll reflect this kind of light that only the other mantis shrimp can see. Because if its prey can see it, then its prey will just run away from it, right? So they have these like secret ways of communicating.
Oh, oh, is it like if we like if humans were to do this, then like if I suddenly see a bright thing in the far distance, it would signal a human.
Right, 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 exactly. Here, I'm gonna send you the link to it. It's really interesting. Yeah. Watch it when you get a chance.
Okay.
And by the way, they have six pupils. We only have one in each eye. They have three in each eye.
Oh,
Yeah, pretty crazy.
yeah. How do they? How does that work?
I mean, it's just their eyes are divided into three, each of them. Like they, for their survival, they live in a. Okay, like cause think about this, right? They live in the water, and water refracts everything that goes in it, right?
Yeah.
So like when you look in the pool, you might think it's closer, but it's actually pretty deep. So because water plays these tricks, they need higher visual acuity to judge distances in water more accurately.
Oh. Um. I'm wondering for like like insects, do they are they uh are they cold-blooded?
Insects, yes.
So in winter they also like their behavior is like slowed down.
Right, right. That's why if you have like a, I guess, a cockroach infestation at home and you try to kill them in the winter, you can usually kill them in the winter
Oh,
because they're slow. I mean, they're not slow, but they're slower moving than they would like be in the summer. In the summer, they're like lightning. It's
huh.
very hard to kill them in the summer.
But then for mosquitoes, then usually in the winter there are no mosquitoes. Is that related to this, or is it because uh maybe they all died?
Oh, good question. Okay. So there's two, it depends. Okay. So I would say it depends how cold it is. So if it's really cold, they die. But what happens is that their metabol, like if you know the larvae, the eggs, their metabolism slows down so much that the enzymes become inactive. But when it becomes warmer, or when the temperature of the water that the eggs are laid in becomes higher, close to like room temperature, then those enzymes are active. And when they are active, they start developing the mosquito larva.
Oh,
So if you have like plants that you water in your balcony, and let's say in winter, of course you keep watering them, but let's say you're like not worried about mosquitoes in the winter, right? You just leave the water like collecting on the bottom. Let's say you don't like look after or whatever. Over time, mosquito eggs can start to like pile up.
huh,
Just because there aren't any mosquitoes at that time doesn't mean that the eggs aren't there. And then in summer, suddenly you have like a horde of mosquitoes coming out from your plants.
huh.
Yeah.
Um, do what's like the cycle of their like the period like one generation how what like their lifespan?
Do you mean like how long do they live?
Yeah, like how long they live and how like when do they reproduce? Is it like they lay eggs every few days or every month or every season?
Oh, so okay, so females live between 42 days to about 50 days. Okay, adults only live for 10 days. Adult males, sorry.
Oh,
Yeah, adult females live between 42 to 50 days, adult males about 10 days. Now, the reason for that is that you only need the adult to procreate, right? But
yeah.
females need to procreate, and they also need to find a suitable place to put the eggs before they die. And this is a seasonal occurrence.
Wait, then so they have like a breeding season or
Right. That's why summer is their breeding season. Because temperature's nice, rain, there's enough rain so they can lay their eggs.
oh then
And mhm.
so like during one half of the year they're like thriving and during the other half they would be the adults would all die off, but the larvae would or like the eggs would be um
Would survive.
yeah they would survive in like water
Yeah,
or until the next half of the year.
right.
Oh,
By the way, I think you'll find this interesting too. So watch it when you get a chance.
Um, so when you detect body temperature, is it the skin temperature receptor, or like is it something else? Because I read that the hypothalamus detects a rise in the central body temperature.
Right, right. So because the hypothalamus and the blood interact, right? Because you have blood vessels around the hypothalamus, it can detect temperature through that because that would make more sense, right? As like you can respond faster to temperature change if you detected your blood's temperature rather than constantly detecting like temperature on your skin, right? But the temperature on your skin is like a supplement to making that decision of are you too hot or are you too cold. So the hypothalamus takes everything into account
Oh,
before making a decision to vasodilation, vasoconstriction, shivering.
oh. Then what if somehow my environment is still normal temperature, but my core temperature is uh decreasing? Then I wouldn't be able to sense that consciously, right?
No, but your body temperature will start to increase because your core temperature is like that. So okay, so if you have conflicting information between your skin and your core temperature, then your core temperature wins out.
Oh, okay. I wonder how other animals react to uh a, a, a lower temperature.
So like, do you mean warm-blooded or cold-blooded?
Or warm blooded.
So you wait. So do you mean like if like let's say a person goes to a really cold country.
Uh, no, like if a dog or cat or a bird is put in a very cold area, then
Like all of a sudden,
yeah, all of a sudden, and
okay,
besides their response for the like hair or feathers, well, what else do they do?
their rate of respiration will increase dramatically.
Oh, then would uh they also do vasoconstriction and shivering?
Yes.
Wait, I don't know about shivering. Do other animals also shiver?
It depends on the animals. So like polar bears will shiver.
Oh,
Yeah.
and what?
And birds also shiver.
Oh, really?
Yeah, yeah, yeah.
Wait, actually, I
Yeah, yeah, actually.
I never knew. Right, then what about cats and dogs? Because I see that they like they use their mouths to breathe to like release the heat. But
Right.
then what about if it gets too cold?
Oh, then they'll also shiver. And then they won't pant as much. Because panting is a sign of overheating.
Oh, oh, okay.
Yeah.
Um, besides like shivering or uh like besides shivering or like vasoconstriction,
Mm-hmm.
what else like can can the body's metabolism increase by itself due to like a signal from the brain, or it has to like be triggered by something like shivering or adrenaline?
So because the hypothalamus controls everything, the thermoregulatory center, it will then instruct the cells to increase the rate of respiration. So when you say increasing metabolism, it's increasing one part of metabolism, which is catabolism, right? Because
Oh,
breaking down glucose is catabolism,
yeah.
right? So it will increase that.
Then so it can be increased by itself from like a direct command by the brain.
Yes.
It doesn't have to be like a indirect. Uh,
No, because increasing rate of respiration, like it's a big thing. It affects your entire body. So the thing that makes the decision is your brain.
okay, yeah,
Yeah.
and yeah, I finished reading.
Excellent. Good. Just in time. So I will see you tomorrow, right?
Um, yeah, yeah,
Yeah. Excellent, man. So see you soon. Have a good night. Yeah.
yeah. Me too.
Thanks, Chris. Bye.
Okay, bye. Damn. COVID policy. Damn. Balls. Chemistry. Jackamot. Metal oxide. Iron oxide. Wait, what? Then what is this? Damn, I don't know this. First is oxidized. Lose electron. What the fuck is this order? 4.
心小感冒變大件事，可以揀必理痛特強傷風感冒熱飲。
Hello everybody, welcome back to another video. And this here, right? And then we also learned how to, we also learned that how to, let me see here, right?
A year ago?
Eric, where's your assignment? Eric? Eric?
What actually happened here?
Justin, waiting. Waiting. Eric, waiting. Lily was late. Gary, waiting. Grace. Grace, where's your assignment? Grace. She's not here. Waiting. Had not handed it in. Please hand it in in the next week. It's very important to get the grades. You don't have a lot of time of the year left. And then you guys are going on exams. You're going to write exams. So please use your time effectively, especially with PE. If you handed it on time, you would have gotten 100%, a 10 out of 10. Now you're at 6 if you hand it in. So if you have not handed in, please, before you start next week. Is that clear? Okay, guys. So enjoy your week and enjoy your Easter holidays, and I'll see all of you back at school next week. I hope you have a lovely week, guys. Bye-bye.
Oh, phew. I didn't get caught. Let's see. Damn, oh shit. Oh, that's garbage form. Oh, that's garbage. Garbage. Oh. Not bad. Skinny ass arms. humiliating. Can't see it, man. More likely to be reached? Potential economic growth can be higher. No more. The goal is able to, yes, and therefore increases the potential productivity. But The heel mic.